Okay, so for your class, we already completed class example 33, where we decided, okay, do we need any additional water holding structure or not? We found out that, okay, for that specific case, we need to construct some water holding structure. Now, most of the time, most common thing to hold water is detention pond. Like after any new construction, most of the time it's the detention pond. Now, that is not the only option. Sometimes, like based on the city or based on the budget, based on the time, you can do lots of different things. Suppose you think that, okay, I will go with more sustainable option, or I will make some rain garden, or all of my parking lot that is a forest pavement. So that can take some of the water as well. So there are multiple options, and your project 4, like the one I just described, I will ask some sort of question like that, like what should be the option? What do you think? There is no right wrong answer most of the time. So you can actually explain whatever you think. Okay, based on your experience or something like that. So here, when we say that, okay, we need to build at least one water holding structure, we also say detention pond is the most common one. Then I thought, okay, let's do one class example, like how to find out the capacity for detention pond. Okay, so class example 34 is actually that one where we will design a detention pond capacity. Okay, so that's what we will do. And that is the very last class example for this course. So who wants to read the class example 34?
Watershed area, 46 acres, in below. Previous development took place for the last several years. For the development, maximum output in the watershed was 50 cubic feet per second. Local government found the ordinance to emphasis development discharge will not exceed the pre-development discharge, i.e. zero excess runoff. Determine the capacity of the detention basin required to excess runoff for 1 hour long rainfall after the development follows up report.
Okay.
The intensity duration frequency relation given by I equals 315 over C plus 25. C is minute weighted average C given as 0.51.
Thank you very much. So there is one thing missing here. I didn't give you the final unit of I, that is actually in inch per hour. That is missing from here. So the unit for I should be inch per hour. Now, what they are saying, this is one area, like 46 acres in total, but there was like 1, 2, 3, 4 subsections. Okay, so for each subsection, there were something C values. You know, if you have multiple C values, how to find the weighted average one, right? Like C1, A1, C2, A2 divided by A1, A2. So I skipped that step and I gave you the direct weighted average C, which is 0.51. Okay. Now, what they're saying for this area, that was the pre-development. Okay. And after this construction, obviously, the hydrograph will be like post-development runoff. Okay. Now, the pre-development, that one, like in total, that was actually 50 feet cube per second. And the CD actually requires that any construction you are making, you can't add any new runoff. Like you need to take care of your thing. Like since you are building something, you need to take care of those excess water. So as an engineer or owner, you need to take care of these excess runoff. Okay, that's what you need to do that. Now, for doing that, you or the designer decided, okay, we will make the detention pond to hold this excess runoff. Now the question is, okay, how can I find the capacity of that detention pond? That's what we will find. Okay, so So in that case, if the detention pond is taking care of this excess runoff, your new construction is not releasing any single amount of water after 15 minutes. So even if you did that, still the total runoff water city will be same. So it's kind of like win-win situation, and that's what they want, that you are not allowed to leave any excess water. So our task now is to find out what is the excess runoff after 50 feet per second, and based on that, what will be the capacity for any detention pond. Okay, so that's what we will do. As a first step, what we will do, we will set all the headings for each column. So these are the column headings here. Okay, intensity, peak inflow limit, rate of flow detain. And for each one, let's add all the unit as well. Now, one more thing, I actually gave you all the time here, but basically what I did, since it says that 1 hour long rainfall, I just split it into like 10, 20, 30, 35, 40, 45, something like that. For any reason, if I don't give you this breakdown, you can actually take any breakdown like 10, 20, 30, 40, 50, 60, or 5 incremental time or 2 incremental time. Like whatever you want to do, you can do that for this 1 hour long rainfall. But here I just gave you one sample breakdown for that 1 hour rainfall. Okay. Now, once you know the time, this time is actually this T, like T plus 25, that T is 10, 20, 30. Can you calculate all the I for column B? Like 315 over 10 plus 25, 20 plus 25, something like that. Can you work on that? And to get the peak runoff from one single area, do we know any relationship with intensity and the area? CIA, exactly. So peak inflow will be Q equals to CIA. Okay. Now, first find out the intensity and let's check if that's the number you got. Okay. Is it a big number? Now, for CIA, what is the final unit we are looking for? Like Q, feet per second, right? But if you look at all the other parameters, A is in area, acre, I is in inch per hour. So we kind of know we need to do the conversion, right? Now there is one interesting fact. We will do the conversion. We will see the conversion factor. At the same time, if you have if A is in acre and I is in inch per hour, you can keep the conversion because automatically the Q value should be in CFS. Now, why is that? Let's check that. What is the conversion factor for 1 acre to feet square? C is C. I don't need to do anything. Inch per hour, acres, right? Now, from, and this one should be feet cube per second. So from inch to inch, how can I convert that into feet? From inch, I need to divide that by 12. Okay, so that is the feet. Now from hour to second, what I need to do? 1 hour equals to 60 minutes. Each minute has 60 seconds, right? Okay. And do you know 1 acre equals to how many feet square? 43,560 feet square. Now, what is that number? Can you tell me that? What is that number? Almost like 1.008, something like that, right? So that's why if you have the I is in inch per hour and the area is in acre, you can skip the conversion. But if you want to do the conversion, do that. There is no restriction or something. Okay, does that make sense to everyone? Okay, great. In that case, can you calculate the Q for column C? What will be the peak inflow? CIA. Do we know the C? 0.51, yes. So just check if you got these numbers or not. Yes, that's what missing in the question. So make sure you just add that. And make sure you save the solution. Okay?
Could you multiply the 0.51 by the 1.008?
No, that is just the conversion factor. If you want to convert that into feet cube per second, or like if you convert all the inch per hour and acres. So what you will do, the C is 0.51. What is the I? 9. What is the T? Sorry, I and the area. What is the area? 46, right? So 0.51 multiplied with 46 multiplied with 9. And let's add one more row here for time 0. I'm not doing anything for 0, but just add one more row here for the 0 time. Okay. So for the 0 time, basically peak inflow will be 0, and I'm not doing anything else. So just for 211, it will be CIA 0.51. I equals to 946. That is 211.1. Check that if you got all the values like that. What will be the next column? What is the next column? What is the limit? Is there any limit here? 60, right? So all the column for that, all the row cell for that column will be 12. Just 60. Here. Okay. Now, can anyone tell me what amount of water I need to take care of? Do I need to take care of that 211.1 cubes per second water, or I need to do something else? The 50 is the allowable limit, but I'm producing 211.1. So I need to take care of what? Except the extra thing which is after 50, right? Does that make sense to everyone? The 50 you can within after 50, but you're producing 211, so you need to take care of that 161, something like that, right? So the next column, rate of flow detain, like what amount of flow you need to detain, what will be that one? How can you find out that? Exactly, exactly. That's what you will do. So this one will be like rate of flow detained. That one will be peak inflow minus peak. That should be peak outflow limit actually. This one. Okay. All of you got that? Everyone? The last row? Then you got that? Okay. I think that will be the better word, like instead of peak inflow limit, maybe the peak outflow will be better one. Because inflow is whatever you are producing and 50 is the allowable one. So maybe, yeah. But you know what we are talking about here, right? Okay, now the next and the last two parts. Now, what is the unit of all of this? Rate of flow detained, right? But when we say the capacity of detention ponds, we basically talk about the volume, what amount of water pond can hold. So, what is the way I can convert the rate into volume? Rate equals to volume over time, but I want to get the volume. So, what I need to do? Multiplied by time, right? That means in between two times, what is the volume, like what is the difference? I will just multiply with that time, like time increment or something like that, right? So the next one is incremental capacity. Like each time increment, what will be the capacity? So you need to make sure one thing, all the time increment is not same here. So up to 10 minutes, what is the time increment? Up to 20, what is the time increment? 10. Up to 30, what is the time increment? But up to 35 minutes, it's 5, right? So basically, what you need to do, incremental time capacity will be like 161.1 multiplied with 10, and after that, what will be that? Let's find out that. Okay. Yes, that's correct. That's what I was just about to say, that for finding this one, it will be 161.1, 10 minutes. But I can't work with minutes. What I will do? I will multiply with 6 to get the second, right? Okay. And you can do that manually, like 10, 10, 10, 5, 5, 5. Or you can just set the equation in a way that it will take the time difference from the previous one. Okay. So suppose for this one, 36.9, like the way I did, 36.9 multiplied with the time difference between these two and 60. Okay. Yeah. So that's why it's important to check what is the time increment here. And you can actually make it automated just to connect with two time increment here so that you don't have to think that much. Okay. And if you do that, I got these values. Check that if you got that one or not. Check if that's the number you got. Check every column. Okay. Now these are in the incremental capacity, like each 10 minutes, that amount of water is added to the pond. So by the end of 60 minutes, what will be total volume? How can I find that? Either you can find the, like, if the question was, what is the capacity after 60 minutes, you can just add all of these. But if I want to know what is the water volume after every 10 minutes or something like that, what I will do, I will just keep adding here, like the cumulative flow. So the very first one will be just 96684. What will be the next one? 96684 plus 68552. The next one, you will add the third one. It's like you will keep adding till the last point, and all the values you will get will be kind of like that. And let's check what I did here. So this 16215 is actually 96684 plus 68532. And the next one, we keep adding. Okay. So all of you got the numbers I got, or okay, everyone? Okay. So that simply tells us like every 10 minutes or every 5 minutes, what will be the total volume of water that detention pond should contain. So if you design a detention pond for 1 hour long rainfall, that should be the capacity. But if the rainfall is less than that, that's okay. That pond can still hold that amount of water, right? And if the rainfall is more than that, that detention pond should have some outlet so that water can go to some other point after 1 hour rainfall. Does that make sense? Okay, great. So yeah, that's it. So that is the capacity. There are lots of well-established chart and everything. That if we are concerned about the hydraulics, we go through those charts and find out what is the actual size of the detention pond, like slope, length, with something like that. But since here we are not doing anything hydraulic, so I will just stop here, like that is the capacity for each detention pond. Okay. Okay. So yeah, that's it for class example 34. And